Full disclosure, guys, it is 11:30 at night and I cannot for the life of me sleep. So I thought, why not try to record a video? So today I thought I should introduce a new topic of ratio and rates. So with ratios, obviously there's two different subjects. So there's ratios and there's rates. Ratios are used to compare different quantities. They can be used to describe money exchanges, ingredients used for cooking, or perspectives in drawings. It can be used for many different things such as those. Rates enable us to compare quantities expressed in different units. So while ratios are used to compare different quantities, it's usually the singular unit, while rates can be used for many different units. So let's just say, as an example, how far a family's car can go with 30 litres of fuel at an average speed of, say, 60 kilometers an hour. So for now, let's focus on ratios. So ratios are used to compare different quantities of the same kind. Ratios do not have a name or unit of measurement. The order of the numbers in ratios is important. If a ratio of flour to water is 1:4, the 1 corresponds to the quantity of flour, while the 4 corresponds to the quantity of water. So pretty much a 1:4. If flour was mentioned first, so then that 1 relates to the flour. 4 was said second, so that 4 relates to the water. So ratios can also be written in fraction form. So 1:4. So it'll be on the screen what 1:4 looks like. But 1:4 can also be written as a fraction as 1/4. So ratios can also be written as percentages. For example, if 20% of the year 8 students walked to school and 80% didn't walk to school, the ratio would be 20:8. But then with ratios you simplify it, so it can turn into 1:4. And remember, ratios have to be in the same units. If you're given an example of, like, say 10 centimeters and 1 meter, that meter needs to be turned into centimeters, or that centimeter needs to be turned into meters. It's really important that ratios are kept in the same unit. And one of the most important things is to simplify a ratio. A ratio of 2:4 can be 1:2. A ratio of this and that will be this and that. So ratios containing whole numbers can be simplified. Ratios that don't contain whole numbers, like so decimals and stuff, I wouldn't simplify them. So I thought, it was only a bit of information on ratios, but I thought I'll leave you with that because ratios is pretty simple, and reading the examples and going through the work, I feel like you guys can already do most of this, pretty much all of this. This is really, compared to Pythagoras, this is probably the easiest thing you'll do. This is pretty much a give me. So I expect obviously the work to be done. I expect everything to be done. But yeah, and obviously to your best abilities. This stuff is really simple. It's really easy, and honestly, it's what I want you guys to achieve a lot in this chapter. So I thought, why not try to record a video?